topic for wired and wireless connectivity. 4.14 is the reference for it, Edexcel GCSE Computer Science. So the ideas here, in the previous video we talked about LAN, local area network, and wide area network. To form these networks, we may have a range of different mediums to send information. Fiber optic is using light going through a fiber optic cable, so obviously you can imagine the speed of light is extremely fast, so times 10 to the 8 potentially. Obviously it's not going to be quite as fast as that in a medium, but it's going to be very, very quick. So if you're sending information cross-continental, through huge underground, the sea might be here, and then at the bottom of the seabed there might be a huge fiber optic cable sending information from, say, Great Britain to all the other countries around the world. So fiber optic cable is using light, or pulses of light. And then typically, still in most households, it will be copper cable going to a little box. So outside on the street there might be fiber optic cables going to that box outside on the street, and then from the box to your house might be copper cable. There is a limit to copper in terms of how fast connections can be, but slowly houses across the land in the UK at least are starting to go to fibre to the house, which is good because it will make things quicker. And there are a number of different ideas that we need to talk about, so I'm going to make a little chart here: wired versus wireless. Okay, so wired, we can have what we call transmission speed. Okay, with wired, super fast, consistent. With wireless, it's typically slower. Okay, even though wireless has got a lot better, you've got like 5 gigahertz connections now, but it's still going to be slower than any wired connection. Then we have the range, right? So Ethernet over copper wire, like the one I just described going to your house, probably going to be about 100 meters, still quite far. And fiber optic, like the one I was just describing earlier, that could be like 60 miles, something like that. So you go over to France easily. Wireless hotspots, which you might find on a ceiling. If you've got a room, you might have a little hotspot, little access point, you can call them. They're going to have a range of 10, sort of a very different sort of smaller reaching range. Depends on how many walls are in the area, how thick the walls are. But they're very limited to a small area, essentially. Sort of tens of meters. Then you've got another idea here: latency. Right? The latency is the delay in the signal. So very low for wired, very low delay. So it's a period of time taken for information to travel from one source to its destination. So you've got A to B, how long that period of time would be, the delay in it. Greater latency with wireless. It's all common sense so far, isn't it? Particularly if you've got things like satellites involved as well. Different error checking protocols, because you might have overlapping Wi-Fi signals. And this goes into another idea called bandwidth. So the bandwidth is the volume of data. So, okay, so I'll put in here volume of data that can travel along a cable any particular time. Okay, that's essentially what bandwidth is. So how does this change in different mediums? Bandwidth is typically shared in Wi-Fi connections. So all the different people connecting to that access point are going to be sharing a slice of the cake. Really, if you imagine a cake with different slices, how many users are taking that? They're all going to be. It's going to be generally a lower bandwidth than a wired connection. There'll usually be a dedicated bandwidth. This is all contingent on the internet service provider, like the ISP, whoever makes that box. That's going to be, it could be capped at 200, something like that, 200 meg line. For schools, it could be more. But so the bandwidth is ultimately how much we have available and how many people are using it, and how we can split it up. Fibre optic cable can provide a much greater bandwidth than copper cable. Okay, it's a much greater volume of data can be transmitted. And the other idea we need to talk about is interference. Okay, so interference, copper could be electrical, magnetic, susceptible to those. There could be issues related to copper connections. What avoids that is fibre optic. When you have fibre optic cables, it's not being interfered by any other electricity fields or magnetic fields. So, but obviously it's more expensive and more fragile as well. Wireless signals can be reduced by walls. So if you've got a wall, that wireless signal coming from this this access point could be blocked, and affects the communication speed. So let's have a look at some questions. I know there was a lot of information there. Let's have a look at some questions. So the performance of a network depends on speed, range, latency, and bandwidth. So pretty much all the things we talked about. In a wireless environment, network is consistent because the capacity of the network is not affected by other environmental factors. Explain 2 ways the performance of a wireless network can be affected by its environment. Well, keep this simple. So wireless, short range. I think that'll give you a mark. Walls and ceilings, or floors, let's say floors, can block the signal. So, therefore, or because, it's best to, when you have an explain, link them with because. So wireless networks have a short range because walls and floors can block the signal. That could be one answer there. Wireless signals might not go very far because solid structures, steel beams, that kind of thing. High latency because they suffer from interference. There are lots of other devices with other Wi-Fi kind of floating around in the same area. Wireless networks can be affected by that interference if there's different frequency bands, such as if there's a microwave in the same vicinity, that can cause problems, all sorts of issues like that. That would be enough there to sort of talk about, think about your home and what affects your wireless signal at home. You just go for sort of common sense answers for that. Network speed is the current rate of data transmission. So it's asking to define the term bandwidth. So you want to use words like volume, a volume of data. That's what we looked at earlier. So you can say the maximum volume of data that can be transmitted per second. It would be nice to have in there, wouldn't it? I think that would be enough. You could say full capacity. That would be another word you could use. Network protocols control the rules of communication. Name a network protocol that transmissions from other electrical devices can interfere with and can be blocked by walls. Don't overthink this. If you get a question like this, don't overthink it. Wi-Fi. Or you could put Bluetooth. You get a mark for that. Bluetooth is short range communication. It's designed to be talking to devices that are very near and lower and uses lower energy. Networks are described in many different ways. Give the type of a network that covers a small geographical area. Again, just think about your school. What was that? That was a LAN, wasn't it? A local area network. With this kind of question, I would be tempted to actually write it out, just to be safe. Name the characteristic of a wireless network that is measured. Well, the only thing that can be measured in meters is the range, isn't it? That's one of the things we talked about, the range. So wired connections could be like 100 meters, for example, copper wire, but fiber optic could be 60 miles. So that gives you a range of the kind of questions that you might see. I should also say that copper cables are not of light pulses, they are electrical signals. So they're going to be slower, still very fast, but slower than the pulses of light in a fiber optic medium.